Hello friends, in this video we are going to talk if RAG is really dead and what can we do about it. My name is Michael and I'm building AI-powered applications for living, and the truth is that most AI apps and automations has to use some sort of RAG approach to accomplish a task. And honestly, I don't see how we can put this approach to grave with the current state of the models. This video can be divided into three parts. First one is the overview of the RAG, so how it works, what are the main components, and also the basic implementation. Then in the second part, we are going to dive deeper and understand what are the main three challenges and issues of such applications, and basically how we can measure them and evaluate the performance of such systems. And in the third one, we are going to discuss the potential strategies to make those applications better and hopefully make it work in production environment. Okay, so if you don't know what RAG is, here's the short summary for you. LLM by its own is pretty useless, and there are two main limitations we need to overcome to make it useful. First is that it cannot interact with the external world by its own, and the second one is that LLMs don't know anything about your internal data, hopefully. So in order to do anything meaningful for us, we need a way to provide this additional context to the prompt. And the way to do it is basically RAG, for now at least. So here's the short diagram of how this works. First, we need a way to build our internal database for AI, and that's called ingestion. So we got our files or any other sources of informations, and we need to basically divide it into the smaller pieces called chunks. And then we use the embedding models to create the embeddings, which are basically the number representations of the text. So it's basically an array of numbers, and we store those embeddings in vector database. So that's the part one. The second part is basically retrieval part, where we've got query from user or from any other sources, and we use the same technique. So we basically create embedding out of this query, and we use something called similarity search to find the relevant informations from the vector database. And the third part is where we make inference with the LLM, where we provide the query, the retrieve context from the vector database, and in many cases additional informations and rules. And that's how basically RAG works. Okay, so here's the code, and we are not doing anything fancy. This is really simple pipeline, but it's enough for the sake of this video. So let's start with the imports. And then let's define the language model we are going to use, which is GPT-4o Mini, and the vector store. Okay, so here we're starting to working on the ingestion part of the RAG system, where we load documents. So basically in data folder, we've got the PDF files with information about companies that are working on AI at the moment. And we use PyPDF loader to basically get the informations from these files. And as discussed, we need to split those documents into smaller pieces called chunks. And to do it, we can use something called recursive character text splitter with such parameters. And you can play around with these parameters to basically make your retrieval better. And we've got this text splitter, and basically we use the function called split documents, where we provide the loaded documents from the previous node, and that's our chunks. And then we need to add those chunks to the vector store. So we do it like this. And the thing is that we don't need to manually create embeddings, because when you define the vector store, you provide the embeddings function right there. So let's execute this node, and that's how we create our database for the RAG system. Okay, so now let's implement the retrieval and answer generation parts of the RAG, and we'll use LangGraph to do it. So we need a state for our graph, where we are going to have the query. Context is basically the retrieve information from vector database, and the final answer. And if you want to retrieve information from vector store, we can use function called similarity search, where we provide the query and the number of documents you want to retrieve. And as before, where we added the documents into the vector store, also here we don't need to transfer the query into embedding by ourselves. The vector store is going to do it for us. So we've got our retrieve information, and we put it into the context. And the second function is generate answers, where we basically put the content of the documents and the query into the prompt and ask LLM to answer the question based on the provided context. So now we've got the function we want to use, and let's put it into the graph. So we define our graph with our state. We add the nodes, so the retriever and retrieve node and the generate answer node, and we connect the nodes with the edges. So we put the edge between start and retrieve, then retrieve and the generate answer, and from the generate answer is the final node basically. So now we should have everything ready. So let's ask about what is DeepMind. So we just invoke our graph, and we see that it's retrieving documents, generating answer, and we've got the answer that DeepMind is officially known as Google DeepMind, blah 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 blah. Okay, so why people hate RAG? Simple and short answer is it doesn't work 100% of the time. Simple as that. And the truth is that the systems, the AI to be precise, doesn't have access to all the knowledge when it creates the answers. It needs to rely on the information that are retrieved from the vector database, and we can do it with some percent of accuracy. Also, which is really important, the performance of this system degrade over time, and in many cases is due to the growing data sets, which leads to the bigger problem with retrieval accuracy. And the third part, what makes it even worse, is that those pipelines are quite easy to implement as the POCs, as you could see a few seconds before. And business leaders are often amazed with the initial results and want to speed up the process and put them into the real world, basically too soon, without putting any evaluation metrics and monitoring systems in places. And in many cases, this results in shutting down the projects due to lack of trust from the user who use the applications and the business owners itself. So how we can make it better? And we basically need to understand the three main problems of these systems, how to measure and evaluate them, and basically only then we can address the performance issues. So also I should mention that I assume that the data quality is not a problem here. So three most common issues with RAG systems is the retrieval accuracy, context utilization, and answer quality. Retrieval accuracy is the problem when we are missing some critical informations in the extracted documents from vector database, or that we've got too many irrelevant documents basically. The context utilization, on the other hand, occurs when LLM have problem with synthesizing knowledge we provided. So we'll see that LLM ignores some parts of the context. It cannot synthesize knowledge that are divided across many documents, and oftentimes it will also make up some facts, so basically hallucinations. And the answer quality is the problem between the final answer and something called ground truth, so the informations we know that are correct. And we see that the answers are factually incorrect or incomplete, or maybe in some cases even not addressing the original query from the users. So now we understand the most common issues with the RAG system, and happily we can measure them and evaluate those systems, and we can use many libraries to do it, but one of the most popular one is RAGAS. And RAGAS has plenty of many advanced metrics we can use it. And recently they introduced also something called NVIDIA metrics, which basically answers the problems we discussed before. So we've got the context relevance, which basically evaluates if retrieved context is relevant to the user query. So we know if the documents have answered the query basically. We've got the response groundedness, so basically measure how well the answer is supported by the retrieval context. So in other hand, it measure the hallucination level, and the answer quality, so it's checking the similarity between the final output of your systems and the ground truth you prepared. Okay, so what you need to know about those NVIDIA metrics is that they are using something called LLM-as-a-judge. So basically, we are asking another LLM to score different part of our RAG systems, and we are doing it from many different perspectives for the better outputs. And then we normalize those values between 0 and 1 for the final outputs. Okay, so let's implement it. We need our data set. So let's load it and basically let's explore it. So we've got 42 test examples, and each example has the query, so basically the questions we want to ask, and the ground truth, so the expected output. And now we need to find the relevant context, basically from our vector database, and also the result, so the answer from our RAG pipeline. So we got it here. So we basically iterate over each example, we invoke our graph, and we put it into the results are at the end. And also when it finished, we save the result into test results JSON if you want to go back in the future there. So it will take a while, so let's wait. So you can see the progress here. Okay, we successfully generated answers for all the test examples, and we saved it to test result JSON. And now what we need to do is to create evaluation dataset. So we basically turn all the items from the results, and we create the sample here, and then from the samples we are creating evaluation dataset. Okay, so now we can work on evaluation. So we need to initialize our evaluation metrics, basically put a wrapper around the large language model we are going to use as the judge, and basically run evaluation across the samples from our dataset with defined metrics and with LLM. And when it's done, we are going to show the overall results and also show the data frame with all the details. So as you can see, the evaluation is complete. We've got the answer accuracy quite well. It's not really low, but well, it could be higher. It's 0.73 basically. The context relevance is here, and the response groundedness is as follow. And I should mention that you are not going to get the same results every single time because you are using LLM, which is not basically stable, right? And here are the details. So if you want to evaluate anything, you can basically dig in and check what are the problems. So as you can see, making evaluation is not that hard. So now we should talk about what are the strategies to basically improve our RAG. So if we got a problem with context relevance, we need to work on the ingestion pipeline and the retrieval part. So we can work on chunking. So we want to optimize our techniques so we can experiment with different size of chunking and overlapping. Also use something called semantic chunking, which basically divide text based on a structure. So for example, we want to chunk whole paragraph or whole tables without dividing it into some parts. We can improve our embedding, so we can upgrade to newer embedding models, or maybe fine-tune our own model on domain data. And we can basically enhance our retrieval, so we can increase number of documents we want to retrieve. That's the simplest one. We can implement something called hybrid search, so it's semantic plus keyword search. We can add some metadata filtering to the vector database to narrow the number of vectors we are going to looking for, and use something called re-ranking strategies. Also, sometimes the query engineering works great, so we can use multi-query retrieval, or maybe hide. So if you're having problem with the retrieval part, these are the first things to check basically. If you've got problems with response groundedness, First thing to do would be to work on your prompts, basically. But also you can organize your context a little bit better. So you can sort chunks by relevance score, maybe summarize the really long documents into, the essence, remove duplicates if there are any, and also get rid of not relevant chunks, basically. And if it don't work, you can move to advanced techniques such as multi-step RAG processes or maybe agentic RAG. There are many different approaches you can use. And if the problem is in answer accuracy, I would start with refining instructions for the LLM, so specify the output format, etc. And then move to quality control and answer improvements. So in quality control, you can use LLM-as-a-judge for evaluations if there are some missing informations, and you can basically go back into the process with some additional information. And it can implement something called self-critique mechanism also. When it comes to answer improvements, you work on the final part. So basically you can do something like two-stage generation when you first create the draft, and then in next inference you refine based on some criteria. You can also create multiple answers for the one questions and select the best one. And also because sometimes those systems output the incomplete responses or maybe responses that are not relevant to the query, you can filter these responses and ask one more time to generate the answer. Okay, so to sum it up, RAG applications are not that hard to implement, especially to the level of POCs where we want to test ideas. But when you work on a production-ready system and you don't put enough effort to build this evaluation metrics and monitoring system, and you show the product to the real users, and you get the negative feedback, and well, you will have some, obviously. You won't have any way to tell what should you work on and what are the problems in your systems. Even worse, when you build a system where the knowledge base can expand over time, and you don't have such systems, you won't have information how it performs. So you're basically asking for problems. Hope you liked the video. Thanks for watching till the end. Don't forget to subscribe, and until the next time, cheers.